Alright everybody, this is my first video of the CNC reload project. This is the very beginning. I haven't actually constructed anything yet. I'm just going to go over the theory of operation and just some of the basic parts. So for the control, I'm going to use this STM32. This is a dual core ARM processor. It runs really fast. You can ignore this stuff. These are all CNC controls that I was working on previously. So all that gone. Just this little board right here. Firmware is going to be free and got a lot of I/O, so we can do all kinds of neat things with our press. This, I don't know what to call this, so I'm just going to call it a nut ring. These are 7/8 14 grade 8 nuts. They're hard. I bought these off eBay for, I want to say $12 for 30 of them, I think it was. Got some more in a bag over there. But anyway, these are going to be arranged in a circle so that, and they go fixed in the top of a frame. And this is what the dies screw into. And they just sit up high, probably 6 inches or so. The bottom plate will have something similar, but it won't have nuts in it. It will have shell holders embedded in it. And then you can slide whichever shell holder you need for the case that you're going to process in there, and then that bottom plate will move up and down on its own. And what's going to move it up and down is this ball screw. This is a 25mm ball screw left over from a CNC mill project I was working on. These can be pricey. This one was about $150, but as you can see, it's really long. It doesn't need to be nearly that long. This is going to directly affect the amount of stroke you can get out of the press. This is about 18 inches. So unless we were going to load some, I don't know, 20mm cannon rounds, we don't need that much stroke. So you could get a really short ball screw, say probably just that long, about 8 or 10 inches. Driving the ball screw is this big monster. This is a step servo. Between this servo and this ball screw, should be able to get about 400 pounds of mechanical advantage. It's just driven here on the end, and I can move it from all the way down to all the way up in about 1.5 seconds. So that's a pretty good speed. And it's going to affect directly how fast the press moves up and down. Of course, this being a ball screw, it's also very precise. So if I need to move the press up 0.02 of an inch, no problem. I can get a resolution down to 0.6 of a thousandth with this screw and this stepper. So accuracy is not going to be a problem, and that's basically it. Now, I have an advantage that I have 3D printers, so these have to be arranged and spaced evenly. And I'm starting with this because the bullet feeder, not really going to be that hard to figure out. I already have a pretty good idea how to do that. It's pretty simple, pretty straightforward. The case feeder, same thing. So I'm starting with this because this is more of the complex part. This is kind of the heart of it. So I'm going to 3D print, after I do some CAD drafting, I'm going to 3D print a plate that these will set on. And these corners of the nuts will just barely touch. And they will get tack welded in between the nuts. Just a tack, because again, it's on a 3D printed template. I don't want to melt the template, so I'm just going to tack them. And then I'll take these off. And out in the shop, I've got a surface plate, a granite surface plate. I'll clamp this down and get it good and flat, put some steel under it, and sandwich it between them, and then do a pretty good weld between each nut, and try to keep it from twisting and warping. Keep it clamped down as I go, because we want this pretty flat. We don't want it to end up, bowed or something like that, because that will affect the straightness of the dies in the press. So I've got 12 nuts. That gives me 12 stations, or 12 dies I could screw in here. Now I don't need 12 dies to do standard reloading, but this press is going to do decap and resize, trim, swage, powder, bullet, crimp, seat, everything, priming, everything that needs to be done to a cartridge to get it ready to shoot again. I want this press to do it. So between the hardware that I've got and the software that I wrote last year to control a CNC machine, I think I can do that pretty easy. So this is going to take probably a couple of months to get done. So I just want to kind of document the process, because I am doing this DIY style. I want other people to be able to build it without investing a whole lot of money or time. So all the 3D print files will be available, CAD drawings will be available, everything will be on the Facebook group page. And I'm using an epoxy casting method, which I used to build a very large vertical mill, which is out in my shop. But it's very similar properties to cast iron. So I think this will be a good learning project, and hopefully you guys enjoy it.